Hello, this is presentation 3, and this presentation focuses on confidence intervals. Now, before I begin my presentation, I want to give a little background knowledge on confidence intervals. So, a confidence interval of an unknown parameter consists of interval numbers. The level of confidence represents the exact proportion of intervals that will contain a parameter of a large number of different samples obtained. There are two different types of confidence intervals. One type is if only a population standard deviation is given, and that is when you'll be using z-scores. And the other type is when only a sample standard deviation is given, and you'll be using t-scores. Now, in this presentation, only a sample standard deviation is given, so I use t-scores. Now, before I show you my presentation, I want to explain what I included. So I made sure to show that all assumptions were met. I showed the process of computing a confidence interval, and I interpret the results. And I classified a mercury level based on my results. So yeah, here's presentation 3.
So part A is asking to determine and interpret a 95% confidence interval and to show all necessary assumptions are met. So first thing I'm going to do is write down what we know from the activity. So we know the sample size equals 106. We know the sample mean is 0.210, and we know the sample standard deviation is 0.112. Now I'm going to make sure that all assumptions are met. So the first thing is that we were only given a sample standard deviation and not a population standard deviation. So this indicates t-score. The next thing is that x is normally distributed. And this is because n equals 106, which is bigger than 30 by central limit theorem. So next, the sample size has to be less than 5% of the population. So I'm going to check that by seeing if n is less than or equal to 0.05 n. And I'm going to assume the population is 20. Less than or equal to less than or equal to n. So I'm going to plug in my sample size, 106, and this gives us 2,120. And now we need to check if 2,120 less than 2 equal to than n. And the answer is yes, because there are more than 2,120 yellowfin tuna in Hawaii. So next is the level of confidence, and that is 95%, which is given in the activity. And steps 5 and 6 is where we are going to determine the 95% confidence interval for the mean. And I'm going to start by drawing a picture just for a better understanding. So here's our 95% confidence interval, and here's our t-scores. So from the 95% confidence level, we have 5% remaining. So I'm going to evenly split the 5%, and that is 2.5% on each side. So now that I've drawn this picture, we need to find the degrees of freedom, which is n minus 1. And that is 106 minus 1, and that gives us 105. So with our degrees of freedom, we can go check our table in our formula sheet, and this gives us a t-score of 1.984. So now I'm going to step 6 to solve. So the equation is x bar minus t alpha over 2, standard deviation over square root sample size, an x bar plus t alpha over 2 standard deviation over square root of sample size. And we are going to plug in our numbers. That is 0.210 minus 1.984 times 0.112 over square root of 106, then 0.210 plus 1.984 times 0.112 over square root of 106, and this gives us 0.1884 and 0.2316. So now that I have So now that I have determined and interpreted the 95% confidence interval for the mean, I'm going to move on to part B. So part B is asking what category I would place the yellowfin tuna, and they are going from least mercury to highest mercury. So least mercury is less than 0.09. Moderate mercury is from 0.09 to 0.29. High mercury is 0.3 to 0.49. And highest mercury is more than 0.5. So from these numbers, you can tell that the numbers that match these numbers the most, which is 0.1884 and 0.2316, matches mostly to moderate mercury, which is from 0.09 to 0.29, which includes these numbers. So the last part is part C, and this part is asking if I agree with the National Resources Defense Council because they classified the yellowfin tuna as high mercury. And based on my results, which is 0.1884 and 0.2316, I do not agree with them because my results show that the yellowfin tuna is classified as moderate mercury, not as high mercury, as the high mercury numbers are much more higher. The categories of mercury levels may have been different due to maybe different sample sizes, which have caused the increase, or something else that may have caused increase is the level of confidence.
That is the end of my presentation. I hope you were able to understand the meaning and the uses of a confidence interval from my presentation, and I hope you enjoyed it.